In the quiet, tense years before the massive American entry into the Second World War, a device was forged in secret that promised to reshape warfare itself. It was called the Norden bomb sight, and its legend grew long before its actual performance could be tested under fire. American airmen were taught to revere the device, believing it was an instrument capable of placing a bomb precisely into a pickle barrel from 20,000 feet. This incredible claim was more than marketing, it was a psychological weapon designed to boost the morale of the inexperienced flying crews. The Norden was not merely a mechanical calculator, it was an article of faith for the burgeoning United States Army Air Forces. Engineers and aviators swore an oath to protect the device with their lives, treating it with a reverence usually reserved for the most sacred of national treasures. The sheer complexity of its design, incorporating intricate gyroscopes and mechanical integrators, contributed to its almost mythical reputation. Its secrecy was paramount, with armed guards accompanying the bomb sites even when they were being moved from one classified location to another. The promise was simple: the Norden would turn strategic bombing from a chaotic, area denial action into a surgical, daylight operation. This device was supposed to deliver American industrial might with a level of accuracy that no other air force in the world could match. The press and public were fed a narrative of infallible technological superiority, completely unaware of the technical hurdles yet to be overcome. This myth of pinpoint precision would soon be tested against the hardened skepticism of the technologically advanced German war machine. The Germans, relying on their own formidable engineering, initially viewed the American claims of pickle barrel bombing with outright derision. They trusted in their own robust anti-aircraft defenses and the simple fact that accurately hitting a moving target from extreme altitude was practically impossible. The early reality of the air war seemed to confirm the German mockery, as bomb patterns were often widely scattered across the European landscape. Yet, the vision behind the Norden was not entirely misplaced, and its potential was far greater than its initial disappointing results suggested. The truth lay in the methodical, often brutal, process of wartime refinement and the stubborn determination of the American strategic planners. German engineers and military leaders watched the beginning of the American air campaign over Europe with a mixture of professional interest and outright condescension. They were masters of precision engineering themselves, having pioneered many of the world's most advanced wartime technologies, including the jet engine and rocketry. The very idea that a mechanical device, operated by often undertrained American air crews, could achieve the promised precision seemed absurd to them. Luftwaffe intelligence reports frequently highlighted the massive, indiscriminate nature of early American bomb clusters, often miles away from the intended target. They mocked the American philosophy of high-altitude, daylight precision bombing as an inefficient and needlessly costly way to wage an air war. The Germans believed their heavily industrialized targets, protected by layers of flak and fighter screens, were impervious to such crude attacks. Their own efforts in aerial targeting were often focused on different methodologies, favoring heavy nighttime area bombardment or quick, low-level strikes. Newsreels and propaganda in the Third Reich often featured clips of captured, damaged American bomb sites, presented as relics of a failed technological venture. German technicians openly analyzed the recovered parts, dismissing the Norden as overly complicated and vulnerable to the rigors of combat flight. They compared its complexity unfavorably to their simpler, battle-proven systems that relied more on pilot skill and simpler optical aids. The prevailing view in Berlin was that the Americans were sacrificing safety and survivability by attempting to fly in large, slow, predictable formations during the daytime. General der Flieger Hans Jeskonek, among others, was convinced that the sheer volume of material needed for such a massive campaign could never be sustained effectively. This initial overconfidence stemmed from a misunderstanding of the American approach, which prioritized the destruction of critical choke points in the German economy. The Germans assumed the goal was general destruction, but the American aim was surgical systemic failure. They believed their deception techniques and camouflage were more than adequate to confuse the clumsy optical calculations of the Norden. This ingrained arrogance prevented them from appreciating the potential for incremental, devastating improvement in the American targeting methods. The early failure of the Norden to deliver on its myth ironically became the perfect cloak for its slow, inevitable ascent to a truly effective weapon. The Norden bomb sight, officially designated the Mark 15, was a masterpiece of analog computing housed in a deceptively simple metal casing. Its true innovation was the mechanical stabilization platform, a gyroscope system that effectively isolated the sighting mechanism from the bomber's motion. The bombardier, looking through the instrument, was granted a stable, fixed view of the ground target, as if floating motionless in the air. This stability allowed the human operator to input a series of variables: altitude, air speed, wind direction, and ground speed. The mechanical integrator within the Norden then calculated the precise moment the bombs needed to be released to hit the target. It used a complex system of gears, prisms, and mirrors to solve the highly dynamic problem of ballistics in 3 dimensions. Crucially, the Norden could also be coupled to the bomber's autopilot, an arrangement called the Automatic Flight Control Equipment, or AFC. For the final moments of the bombing run, the bombardier would take control of the aircraft, using the bomb sight itself to guide the plane. The Norden would essentially fly the aircraft, holding it on the perfect trajectory to compensate for wind and drift. This short, critical period transformed the massive B-17 or B-24 into a mere extension of the bomb sight's precise mechanical mind. The technology was so secret that the Norden was often kept under armed guard on the ground and was fitted with a thermal blanket and a destruction charge in the air. If the plane was to crash or be captured, the bombardier's final duty was to activate the charge, reducing the sensitive mechanisms to useless scrap metal. This extreme measure highlighted the importance the U.S. military placed on keeping the complex inner workings of the device hidden from the Axis powers. The Germans were deeply frustrated by their inability to capture an intact Norden, forced instead to rely on fragmented and often incorrect information from wreckage. The secret was not a single, revolutionary component but the ingenious synthesis of known mechanical principles into a single, highly accurate system. It represented the peak of analog computing power, a testament to American industrial and engineering capacity during the war years. The entire American strategic bombing effort was predicated on the controversial and costly doctrine of high-altitude, unescorted, daylight precision bombing. This approach was born from the belief that only an attack in broad daylight could provide the visual confirmation required for the Norden to work its magic. The U.S. Army Air Forces believed that attacking specific industrial bottlenecks was a more efficient use of resources than the British approach of nocturnal area bombardment. The key targets were selected not for their size, but for their critical role in the German war machine, such as ball-bearing factories and synthetic oil plants. The concept was to create systemic failure by severing the few links that held the vast, complex German industrial network together. Massive formations of 4-engine bombers, primarily the B-17 Flying Fortress, were deployed in tight, interlocking combat boxes for mutual defensive fire. This formation was intended to replace the need for long-range fighter escorts, which did not initially exist for the deep penetrations into German territory. The daylight approach carried an immense risk, exposing the slow-moving bomber streams to the full fury of the German Luftwaffe and flak defenses. American airmen were prepared to endure staggering casualty rates in the belief that their precision strikes would hasten the end of the war. The success of the entire strategy rested almost entirely on the consistent, reliable performance of the Norden bomb sight in operational conditions. Early missions were plagued by difficulties, including thick European cloud cover and the sheer terror of flying through intense anti-aircraft fire. Bombardiers struggled to achieve the idealized conditions required for the Norden to calculate a perfect drop, leading to widespread disappointment. However, the consistent application of this strategy, despite the initial failures, forced the Germans into a costly defensive war over their own skies. They had to divert significant resources, including fighter aircraft and anti-aircraft artillery, away from the front lines to protect their homeland. This strategic compulsion to defend the fatherland at all costs became an unintended and critical success for the American bombing campaign. The dedication to daylight missions never wavered, driven by the absolute certainty that precision was the key to ultimate victory. The high expectations surrounding the Norden bomb site were quickly dashed by the grim reality of early operational missions over Europe. The famous pickle-barrel claims proved to be gross exaggerations, often failing to account for the unpredictable variables of the high-altitude environment. Initial analysis showed that the average bombing error, the radius within which 50% of the bombs fell, was often measured in miles, not feet. Clouds and persistent haze frequently obscured the ground, preventing bombardiers from ever sighting their targets for the Norden's critical run-in. The sheer terror of the flak alley, the constant shuddering from anti-aircraft explosions, made fine-tuning the gyroscope-driven device nearly impossible. When an aircraft took a hit, even a minor one, the sensitive mechanical computations were often irrevocably thrown off course. Furthermore, the inexperience of the newly deployed American aircrews added another layer of error to the complex equation of high-precision bombing. Many bombardiers struggled with the lengthy process of alignment and calibration under intense combat stress, rushing the final, crucial moments. The Germans, observing these scattered results, felt entirely justified in their initial mockery of the American technological prowess. They collected and publicized data showing the wide dispersion of bomb impacts, using the failures as a tool for domestic and international propaganda. Skeptics within the American command structure began to question the entire daylight precision strategy, advocating a shift to the less accurate British night bombing model. The bomb site itself was sometimes unfairly blamed for systemic issues related to training, weather, and the inherent difficulty of the task. It was a humbling period for the American Air Forces, forced to confront the gap between technological theory and battlefield application. This phase necessitated a critical re-evaluation of tactics, training protocols, and the criteria for what constituted a successful bombing run. The command recognized that simply possessing the technology was not enough; its effective deployment required a cultural and operational shift. Lessons learned from every failed mission were painfully integrated, slowly refining the entire process from intelligence gathering to the final bomb release. This slow, deliberate path of improvement eventually laid the groundwork for the devastating precision of later campaigns, but only after a high human cost. The turning point in the Norden's effectiveness did not come from a sudden hardware upgrade, but from a critical, strategic refinement of targeting philosophy. The American Air Command reluctantly accepted that the pickle-barrel accuracy was unachievable in the chaos of a full-scale air war. They shifted focus from hitting a single building to saturating a small, specific area within a large industrial complex, a concept known as a point of aim. Instead of aiming for the absolute center of a factory, bombardiers were instructed to target an identifiable critical component, like a power plant or a central machine shop. This change allowed for a slightly more forgiving margin of error while still ensuring that a critical blow was dealt to the factory's operational capacity. The tactical formations of the bomber groups also became more rigid and practiced, ensuring that the lead bombardier, who carried the Norden, could perform his task unhindered. Only the lead aircraft in a formation would use its Norden to calculate the perfect drop, with the following aircraft dropping their bombs automatically on his signal. This method, known as bombs over the target, dramatically improved the concentration of the bomb pattern, making a single, devastating impact more likely. Training for bombardiers was intensified and reformed, emphasizing hours of simulated runs to build muscle memory and concentration under duress. Weather prediction became an obsession, with missions increasingly scheduled only when a clear sky window over the specific target could be reasonably assured. Long-range fighter escorts, particularly the rugged P-51 Mustang, finally arrived, effectively sweeping the Luftwaffe from the skies and protecting the bomber streams. The elimination of continuous fighter threat allowed the bombardiers to execute their pre-bombing run procedures with far less distraction and fear. This combination of better protection, refined tactics, and improved crew training unlocked the true potential that was always latent in the Norden's design. The mockery from the German side began to fade as reports of perfectly centered, crippling strikes on vital facilities started to filter back to Berlin. The war was no longer an impersonal battle of attrition, it was becoming a terrifying, personal duel between the mechanical brain of the Norden and the heart of German industry. The infamous Schweinfurt and Regensburg missions stand as the brutal, undeniable proof of the Norden bomb site's devastating potential when coupled with effective tactics. These raids, particularly the attacks on the crucial ball-bearing factories at Schweinfurt, were among the deepest and most costly penetrations of the war. The ball-bearing industry was a critical choke point. Without these components, the production of tanks, aircraft, and U-boats would grind to a halt. When the lead bombardiers guided their formations onto the target, the resulting precision was a shock to the German defensive command. Instead of a scattered carpet of craters, the bombs fell in a concentrated, lethal pattern directly onto the factory floor and administrative buildings. The resulting damage was so severe that it crippled the German ball-bearing output for months, directly impacting their entire military production capability. For the first time, German engineers and factory supervisors had to confront a new reality of air war, one where their location offered no safety. The American aim was now consistent enough to differentiate between the factory itself and nearby civilian housing, a terrifying display of selective power. One account describes a German engineer watching in horror as a single stick of bombs walked its way down the length of his assembly hall, precisely guided. The industrial complexes that had been built with concrete and steel to withstand general bombardment were now systematically dismantled from above. The precision strikes forced the Germans to engage in a massive and costly decentralization of their industries, scattering production into forests and underground bunkers. This scrambling effort diverted millions of man-hours and vast amounts of material away from offensive production and into purely defensive civil works. The psychological impact of seeing a factory roof expertly pierced by a bomb that should have missed by a mile was immeasurable for the workforce. The air campaign, guided by the once mocked Autopilot, was now accomplishing strategic goals with a chilling, mechanical efficiency. The narrative of American technological incompetence was shattered by the simple, brutal fact of a destroyed, smoking factory roof. The shift in accuracy delivered by the refined use of the Norden bomb sight fundamentally altered the psychological landscape of the German home front. Before the precision strikes, the population understood bombing as a large, randomized risk, a terror that could strike anywhere but was rarely surgical. Now, a new kind of dread took hold, the fear of being personally and deliberately targeted by an unseen mechanical intelligence miles above. Factory workers, once somewhat reassured by the sheer difficulty of hitting their large targets, now felt a direct, cold-blooded menace. The propaganda that had once mocked the clumsy American efforts now struggled to explain how vital, heavily defended plants were being precisely vaporized. The workers understood that if their specific factory was a target, the American crews now possessed the means to ensure their aim was true. This realization contributed to absenteeism and a pervasive sense of hopelessness in the industrial sectors, which was vital to sustaining the German war effort. The morale of the anti-aircraft crews also suffered a severe blow. Their massive barrages, which had once seemed intimidating, were now merely an ineffective curtain of smoke. The bombardiers in the American aircraft, having perfected their technique, would often experience an almost trance-like calm during the final autopilot guided run. They were no longer simply dropping bombs into a general area, they were delivering a payload with the surgical focus of a trained assassin. This sense of controlled, deliberate destruction was transmitted, unintentionally, to the ground troops and factory personnel below. The precision of the strikes was often so startling that it convinced some Germans that a fifth column must have been providing local, detailed targeting information. The Norden bomb sight was rapidly transforming from a piece of technology into a symbol of inevitable American technological superiority and unstoppable resolve. The war was no longer just about who had the most planes, it was about which side could apply its industrial power with the greatest, most devastating surgical precision. The German response to the increasing precision of the American air attacks was a desperate and ultimately failing scramble of defensive innovations. Their initial reliance on heavy flak concentrations and the sheer number of fighter aircraft proved insufficient to deter the determined daylight raids. The American tactic of flying in tight combat boxes provided the interlocking fire necessary to deter all but the most suicidal of German fighter attacks. To counter the Norden's accuracy, the Germans experimented with massive, artificial smoke screens designed to completely obscure the target area. While these smoke generators did succeed in disrupting some missions, the Americans developed tactics to bomb through a gap in the cloud cover or to use pathfinder systems. The Germans also attempted to employ radio jamming to interfere with the communications between the lead bomber and the rest of the formation. However, the Norden itself was a largely mechanical, autonomous system, making it immune to simple electronic countermeasures of the time. A more direct countermeasure was the mass production of high-performance interceptors, such as the Messerschmitt Me-262 jet fighter. While revolutionary, the Me-262 arrived too late and in too few numbers to have a decisive impact on the overwhelming flow of American bombers. The German High Command, in a strategic blunder, insisted on diverting the limited jet resources for ground attack roles instead of air defense. The relentless pressure of the precision bombing forced a critical change in industrial philosophy, pushing factories underground or into camouflaged rural areas. This dispersal was an enormous drain on resources, requiring vast quantities of concrete, labor, and transportation that could have been used elsewhere. The defense against the Norden was a reactive, costly, an ultimately unsustainable effort against an attacker that dictated the time and place of the conflict. The failure of the German air defense to effectively neutralize the daylight raid sealed the fate of their industrial capacity and shortened the duration of the war. Every countermeasure, from smoke to jets, was a tacit acknowledgement that the American precision approach had to be taken seriously. The moment of realization for the German engineering establishment was not a single event, but a slow, horrifying accumulation of evidence and wreckage. When pieces of a particularly successful bombing target were recovered, the pattern of destruction spoke a truth that no propaganda could obscure. They observed that the hits were too concentrated, too targeted, and too repetitive to be the result of mere luck or mass saturation bombing. Engineers, initially dismissive, began to study the salvaged components of the Norden with a new, grudging respect for its complexity and effectiveness. The captured technical documents, though fragmented, provided glimpses into the ingenious gyroscopic stabilization system that was the heart of the device. There was a dawning understanding that the American success was not due to superior airmanship alone, but a fundamental technical leap in bomb delivery. The German High Command finally ordered a serious, systematic study of how to replicate or counter the precision targeting capability of the Norden. This research, however, was hampered by a lack of intact devices and the rapidly deteriorating state of German industrial capacity under the aerial onslaught. Individual German engineers who had once chuckled at the Americans' over-reliance on a gadget now quietly admired its sophisticated analog solution to a difficult problem. They acknowledged that the Norden had achieved a level of integration between human operation and mechanical assistance that was ahead of its time. The concept of a machine literally flying the plane to the target for the final run was a tactical revelation that forced a fundamental reassessment of their own air doctrine. The shift was from seeing the American effort as clumsy amateurism to recognizing it as a formidable, technologically driven campaign of attrition. This professional awe was mixed with a bitter resentment over the costly oversight of having underestimated the American inventive spirit. The ruins of their own factories became the ultimate textbook, demonstrating the chilling effectiveness of the formerly derided autopilot system. The sheer difficulty of developing a comparable system under constant aerial attack meant the Germans could only react, never truly innovate to match the threat. The legacy of the Norden bomb site is complex, often romanticized, and sometimes unfairly criticized in the annals of military history. It was neither the infallible pickle-barrel instrument of propaganda nor the total failure some critics claimed after the war. Its true achievement was its role as an indispensable enabler of the daylight precision bombing doctrine that ultimately crippled the German war economy. The Norden forced a new conversation about the ethics and effectiveness of selective targeting versus the indiscriminate destruction of area bombing. It was the peak of analog electromechanical calculation, a magnificent demonstration of what complex systems could achieve without modern digital processors. Paradoxically, the Norden was rendered obsolete almost immediately after the war by the rapid development of radar and, later, advanced digital computers. Its reliance on visual sighting meant it could never truly function in all weather conditions, a limitation that future systems would rapidly overcome. The technology's impact was not just on the battlefield but in the political sphere, influencing post-war strategic planning and the rise of the United States Air Force. The belief in precision, though initially a myth, became a self-fulfilling prophecy that drove billions of dollars of investment into future targeting systems. The men who operated the Norden were the first to truly integrate the human eye with a complex mechanical brain to achieve a sustained, strategic objective. The famous security oath taken by bombardiers was eventually rendered moot as the Soviets and others quickly reverse-engineered captured models after the conflict. Despite its flaws, the Norden proved that a technological edge, consistently applied, could exert strategic pressure far beyond the simple weight of explosive dropped. It became a foundational stepping stone for the development of modern inertial navigation and advanced fire control systems used today. The story of the Norden is a reminder that technological superiority is not a final product but a process of relentless refinement under the extreme pressure of combat. It remains a potent symbol of American ingenuity, a device that literally guided the trajectory of the Second World War through the crosshairs of a gyroscope. The era of the purely mechanical Norden bombsight has long since faded, yet its core philosophical goal, pinpoint accuracy, defines modern warfare. Today's smart munitions, guided by GPS, laser designators, and advanced digital inertial systems, have fully realized the mythical pickle barrel promise. A modern JDAM-equipped aircraft can strike a target with an error measured in feet, a level of precision the Norden's designers could only dream of. The principles of gyroscopic stabilization and calculating a ballistic trajectory in real time remain embedded in the core of these contemporary systems. The key difference is the substitution of vulnerable, sensitive mechanical gears with robust, invisible digital algorithms and solid-state sensors. The psychological impact, however, remains the same: the fear of an enemy capable of striking with surgical certainty, anywhere, anytime. The story of German engineers mocking the American Autopilot serves as a timeless cautionary tale against technological arrogance and underestimation. It illustrates that even imperfect, nascent technology can, through sheer persistence and strategic deployment, become a weapon of world-altering consequence. The Norden was a transitional technology, a beautiful, analog bridge between the crude bombing of World War I and the hyper-accurate warfare of the 21st century. Its legacy is not only in the wreckage of German factories but in the DNA of every guided missile and smart bomb used by militaries today. The debate over the feasibility of precision bombing was settled not by theory, but by the undeniable, physical evidence left behind on the European continent. The ultimate lesson is that technological advantage in warfare is a race of continuous iteration, where yesterday's flawed gadget becomes tomorrow's defining weapon. The autopilot's revenge, though delivered by a fragile machine, forever changed the calculus of industrial war, demanding an answer that Germany was too late to provide. The silence that followed the precision strikes was the sound of a technological shift, echoing the end of one era and the beginning of another.